What's up, guys? All right, to kick things off, we're going to go ahead and dive into the maci language itself. And we're going to be covering the in-file language, how to use it within a file, and then we're also going to cover it within strings. But once you understand how to do it within a file, then you'll be able to understand it within strings pretty easily. Now, currently, we're just demonstrating maci language version 1, and of course, there'll probably be updates to it in the future. But for now, this is going to show maci language version 1, which is kind of the foundational pieces of the language. Now, the intro video pretty much gave you kind of the full scope and kind of breakdown of what maci is and what its language is all about. Again, being a Python-style data serialization language. Now, if that word sounds scary, just remember data serialization is just like what JSON does, what YAML does, and many other formats, TOML. It's just serializing data in a way that's easily retrievable. So you can easily, label your data and retrieve it as necessary. There's a lot more understanding to it than just that, but let's just keep it simple. But with maci language itself, it's using Python-styled objects. Now, the reason why it's called styled is because even though maci is using like the exact same look and even some of the same syntax as Python objects, I can't call them Python objects because it's not Python, right? However, it's styled after Python, and as soon as it's imported, then it's literally parsed as a true Python object. So if you're comfortable with writing Python data types, primitive data types, which I'm going to demonstrate, then you'll be comfortable writing the maci language. Anyways, let's go ahead and dive in. So the first thing I want to talk about is regular assignment. So here we are in VS Code. I'm going to go ahead and create a file. And just like it mentioned in the intro, you can go ahead and create whatever plain text file you want. Now, for our examples and all future examples, we're going to be creating like a game save data kind of experience. So let's go ahead and do that. So we're going to do test.save. Again, you can call it whatever you want, but I'm just going to call it test.save. So first of all, I'm just going to go ahead and show you all the different data types that you can assign with, and you can effectively use all of the native Python data types, or primitive Python data types, I should say, that you're used to. So the first regular assignment we'll go over is just creating a basic string, and I'll show you the different variations for that. So let's just create a username, and we'll use single quotes, and we'll do something like Johnny88. So as you can see, we created our basic string using single quotes like you would in Python. Now you could use double quotes if you want to. No big deal, that's totally valid. You can also use triple double quotes if you want to. And of course you can use triple single quotes if you wanted to. So, but either one of those is totally valid. I'm going to stick with the single quotes just to keep it simple. But that is how you can create a string in the maci language. And you see the syntax. You have your variable, equal, sign, which is your regular assignment operator, and then the actual value, and data type, which is a string. So pretty easy, pretty straightforward. So now I'm going to go ahead and create another one, and we'll do the integer. So we'll do starting score, and we'll just do, let's just say 100. And so let's just say the game starting score is 100. We don't even know, we're just making it up. But as you can see, again, regular assignment, just like you're used to in Python. You create your variable, your equal symbol, which is regular assignment, and then your integer. Now, as you can see, it's totally valid to use underscores, and this actually follows the same naming convention as Python. So you cannot start with a number. That will not work. That will be invalid and not process or parse properly. But of course, you can start with an underscore. You can start with a lowercase, uppercase, doesn't really matter. As long as you follow the Python convention, you'll be able to follow the maci convention. So the other thing with an integer is you can, of course, use underscores as well. So if you wanted to do something like that, that's totally valid. Again, essentially following the Python convention, so that's totally valid as well. So let's move on to floats. So let's go ahead and do something like money. We'll just do like I don't know, let's do $1,000. Let's just say we have money and we have 1,000. That's going to be your floating point value. I think you guys pretty much get it at this point. So let's just continue down the list of primitive data types. So let's do a Boolean. And we'll do something like is alive. For now, looks like that's true. And then next we'll go ahead and create a list. So let's do items. I don't know. Let's just do like knife. Let's do shield. And then we'll do something like boots. So there's our items list. And then we'll go ahead and create a dictionary. So let's do something like inventory. And we'll do something like sword. And we'll call it like, let's see, the iron sword. And then we'll do just one more. And we'll call it maybe bow. And we call it like the steel bow. So let's go ahead and create a tuple now. We'll create another one called like special items. Something like emerald. Topaz. Gold bar. And I'm just making these up as we go. But so far, hopefully it's understood on what you're able to do. The next one we'll go ahead and do is a set. We'll call this unique items. Master shard. I don't know. Rare. I don't know. Leather. We'll do fire. Star. Now we'll show the none type. Do something like shield. Equipped. And we'll just do none. And then we'll demonstrate the byte data. We'll just do, this is probably more internal information. We'll just do like process data. We'll do a byte string. We'll just do data. No big deal, nothing too fancy there. And then I'm going to show you the rest, which is more specific to maci. But for now, just take a look at this and I'll kind of walk through each one. But this is all like Python style data. You know, you have your string, your integer, your float, your Boolean, list, dictionary, tuple, set, none type, and bytes data. That's kind of the 10 primitive Python data types that we're all used to. Now, just like I showed with the string, you can also use double quotes and triple quotes if you want for each one of these inside of the list, dictionary, set, tuple, if you want to do that, and same with the bytes, but I just wanted to keep it simple and use single quotes. Of course, we're just having fun with a little game save file, but that's the basics in a nutshell. Now I want to show you the date time possibilities that you can do with maci. So with maci, this is an extended feature, kind of going beyond Python a little bit. And that's the ability to have date time values inside of your files. Now, some other serialization languages out there do have their own support for date and time formats as well. I believe something like Toml does, but maci does as well, and kind of allows you to have a mix of different ways to write it out. So I'm just going to write a single variable name to just kind of demonstrate all the different variations you can use for the time format or date time format. And when this object is parsed, or name is, or I should say value is parsed, it's going to give you a date time object in the runtime of your Python code. And when I say variable, it's actually going to be an attribute name, which you'll kind of later understand in the future videos. But let's go ahead and do something like game save time. Something like that, you know, just something generic. And so I'm just going to pull from the documentation and just write, what is it, 2023 1202. And we're going to do 21 48. There we go. So first of all, I just want to call out, The date times used is actually an Easter egg hint, and I am not going to tell you what that is, but if you do discover it, give a comment or shout out if you figure it out. Anyways, this date time format is a very common industry standard, which kind of follows what's called the ISO 8601 format, and this is pretty common. So you always start with the date and then the time, but maci essentially allows you to do different variations. So this is probably the most common one that might be used. And if you're not familiar with this, year, month, day, and then we have hour, minute, second. But maci also supports other variations in ways to write this. So you can also do microseconds, or I guess that would have been fine as well. I'm just kind of following the documentation just to kind of do a one-to-one. But this would give you the microseconds. You might say, well, that's actually milliseconds if you think about it, because after second would be milliseconds, right? At least for the datetime parsing inside of Python, this actually can be expressed fully in microseconds, because you can go all the way up to this point, and I believe a little further, but it's going to see it as microseconds no matter how you write it. You can look at Python's documentation for that, but it's going to see this as microseconds. So anyways, you can write it like that to get even more accurate precision in time if you need to. And that's the second variation that you can write. So first we just have seconds and then microseconds. But you can also write your timestamp like this if you'd like to. You can also do time and then date, and maci will be able to parse this no problem. Again, it's going to parse it as time and date, but it's going to see that and return the date time object as you would expect. So that's also another variation you can do. And of course, you can add the microseconds on here if you'd like. That's totally valid as well. And then I'll just undo it. We can also write it expressed in the other common ISO 8601 format, which would be a T. And we can even expand on it a little further and do something like 0600. And this would be parsable as well. If you're not familiar with this format, just look it up. Again, it's ISO 8601 time format. So you can express it like this. And then you can also, if you don't really want to include time, you can just express just the date. If you just want to do date only, say you just want something to be looked at on a certain date, you can just express the date, and maci will parse just the date object, and you'll get, well, the others I showed were just all date time objects that are being returned. So this, if you just express the date only, you're just going to get what's called a datetime date object. So it's really just a date object from the datetime module. And so as you can imagine, if you were to just express the time, same concept. You can also just get the time back if you just want, and if you guessed it, it'd be a time object. So it'd be datetime.time object back. So if you just wanted to express time only, you can also do that as well. And of course, you can add microseconds on here. Same thing, it would still be just the time object being given back. And that's all the primitive data types you can write in maci, and we were also demonstrating how to do regular assignment inside of maci, which is using what maci classifies as the regular assignment glyph, which is literally just name equals value, right? So now what we want to talk about next is the lock assignment glyph. This is where we introduce new features from maci that is completely unique to maci. So within maci, we have this feature called locking, which is using the lock assignment glyph. And this feature protects against an attribute name from being reassigned, right? So in code, if you wanted an attribute name, pick one, whatever one you want. If you wanted to protect it from being reassigned to a new value completely, you can lock it and protect it by using the lock assignment glyph, which kind of creates somewhat of this constant-like protection, like if you were creating a constant. Now, even though it's called lock, this is more of a soft lock, and we'll talk about the hard lock right after, but this is more of a soft lock because it only protects against reassignment. So you can pretty much decide how you want to use that, but the way to write it It's quite simple. Let's just say we wanted to lock in our money. So the way you would write any kind of feature assignment glyph that's beyond the regular assignment, you would start with just a plus symbol, and then you go ahead and add literally the letter L. So the letter L, well, stands for lock. We're literally saying I'm, enabling a feature, we're using the letter L, and then you would just use your assignment like you normally would, which is the equal symbol, and then you assign it to that. So that's going to be loaded in. It's going to be parsed as normal. But anytime you try to reassign this name to a new value, it's going to block it. It's basically going to throw an exception. And, during the runtime of the code, it's not going to allow you to change it. So even if you catch the exception, this value will never change. So no matter what happens, this value is never going to change, even if the exception's caught. Just want to make that known that this value will not change, which is protecting your value, locking it. Now, really, I want to make this clear. This is not really protecting the value per se. This is protecting the name, right? The end result is that we're getting our value from being changed, but that's because we're keeping our name from being reassigned. I just want to make that clear. This is just protecting the name. And the reason why I say that, if you're not familiar with this, some objects are immutable. So an integer is considered an immutable object. A string is considered an immutable object. A list is considered a mutable object. And I'm trying to say it without saying immutable, because it almost sounds like I'm saying mutable and immutable at the same time. So an immutable object always has to be reassigned, right? Anytime you create a new string or get a new number value, you always have to reassign the name to that new value. And that won't happen in this case. However, if your name is assigned to a mutable object, so let's just go ahead and do that real quick. If your name is assigned to a mutable object, this object can still be changed itself, right? So we can change any values in here. We can append new values, but that's because it's a list and it's a mutable object, so it allows us to change it. But we're not reassigning, right? We're not reassigning this name to a new value. We're just changing this object in place. So this functionality will remain the same. And I just want to make that clear because I don't want to throw out that it's completely locking your value. What it's doing is just locking your name from being reassigned to a new value. So hopefully that makes sense. We'll go ahead and leave that one there too and move on. But that's the basic syntax. That's all you have to do to lock a name from being reassigned. Really simple. So now let's talk about the hard lock assignment glyph. So the hard lock assignment glyph, since you already understand the syntax, and maybe you guessed it, all you'd have to do, let's try this on the unique items, is we'll just activate the feature and do H for hard lock. So if you activate hard lock mode, hard lock is a feature that protects an attribute name, which, we're calling these variable names, but remember, it will be called an attribute name. Later you'll see. But it protects an attribute name from being reassigned or deleted or unlocked. So I didn't mention this, but with the lock, the soft lock, we'll just call it the soft lock, but just locking, you can actually unlock. If you need to make a change, you can actually unlock it in code and then relock it if you need to in code. But with the hard lock, as soon as you set the hard lock, it's permanent through the runtime of the code, right? So as soon as an attribute name is hard locked, you cannot reassign it to a value, just like the lock does, but you can also not delete it. So you cannot delete this name at all. It will completely block you from deleting that name and throw an exception. And it cannot be unlocked. In fact, the unlocking mechanics don't even search for hard lock names. They only searched for the regular lock names or the soft lock names. So unlocking is not even possible either. So the only way you can actually remove this would be to delete your entire object, which I haven't gone over yet, but when you load this file, this is going to be represented as an entire single object for your data. So that's the hard lock ability. Now the next ability I want to show you has nothing to do with locking. The next one is what's called mapping, which is using the map assignment glyph. So mapping allows you to map a name to another name. This feature allows an attribute name to follow another attribute name's value, essentially. And you can use this map assignment glyph to set the value to be the name of the attribute name you want to follow. This concept effectively gives you like a pointer-like ability. If you're not familiar with pointers, you can look into them, but this is essentially what it gives you. And it really does give you almost a true feel of actually pointing to another name, because you're actually pointing to the same object in memory. Now, this is not a true pointer, but when you look at the values of the names being referenced, they're actually pointing to the same object in memory, even if the parent name gets reassigned. But to make sense of this, and just to show you what all you need to do to follow another name's value, is let's go ahead and create, let's just say, inventory view. And let's say you have another attribute name or variable name that needs to follow what's current in the user's inventory, for example, and you need to always follow that, but you want to create a dedicated name that's always following what's in there and use this name for another functionality, for example. So all you'd have to do is type the name. Now there's more to it. We need to activate the feature, and that's it. So now what's going to happen, we do M for map, right? So pretty straightforward. Try to keep it straightforward, is M for map. And we're saying now we want to map this name, which is going to become the child name, to this name, which is inventory. And so Maci's going to set up a mapping between this name, and then this attribute name or variable name will have the current value of this name always. And this could be anything. This doesn't have to be like a mutable object. You can also map to a, immutable object if you wanted to. Let's say I wanted to do like username. You could totally do that as well. And so if username changes, this will also change as well. That's just the way, the Maci's mapping system to follow the references work. But for now, we're just going to go ahead and select inventory. But yeah, that's all you have to do to set up the mapping. And so anytime this variable name changes, this will always follow its reference. Whether it's in a mutable object or in an immutable object, it's always going to follow it. Now with mapping, it's also possible to create kind of like a chain-like structure. And I'm going to just copy and paste the code from the documentation just to kind of demonstrate what that looks like. Kind of veering away from our little example here. But if I just paste that real quick, just kind of ignore the top here. So we have this name, right? This is our parent name, and this would be creating like a chain-like structure. So if we actually say name equals data, that's our initial value. And then there's a second name that we create. And now we're activating the mapping, but then we're pointing it to name 1. And then you can probably see that once we get to name 3, now we're pointing it to name 2. And then name 4 pointing to name 3, right? Name 5 pointing to name 4. And so now we created this kind of chain-like structure. And if you can imagine, if this parent name ever changes, then this will update, right? Name 2 will update. And because name 3 is connected to name 2, name 3 will update, name 4 will update, and name 5 in like a chain, one after another. And this is all described in the documentation, but I just wanted to make that known. You can create like a chain-like structure, and just whatever kind of architectural design you're trying to create, you can do something like that. Again, also borrowing from the documentation, you can also do like a keyring-like structure. So before there was a chain, and now a keyring structure would be essentially, this would be like the ring, which is the parent name, but you see all of them are actually mapped now to the same name, and you can totally do it that way as well. if you can imagine it, name one is kind of like the key ring, and then these are all the individual keys connected to the same key ring. So those are kind of like two different ways you can go about it. If you wanted to have multiple names mapped to either the same name or kind of chain link different names. And so that's totally possible as well. So going back to our original example, I'm going to show the rest of the glyphs that you can do. And so far, we've pretty much demonstrated lock, hard lock, and map. Those are the three primary feature glyphs that you can do in maci. And really what's left is you can actually mix and match them. Before I show this, something I almost forgot to mention about mapping is with mapping, the name has to pre-exist before you can map a name. So if I did something like inventory 2, this is actually going to throw an exception. It's going to say that this name does not exist. So it's not going to, maci's not able to find that name that you're trying to map to. So the name has to be initialized beforehand. So you can't do something like, let's do this, for example. You can't do something like this. Like, even though this name exists, you are assigning this name to a name that hasn't been initialized yet. So this name has to be initialized first before you can actually assign it. So if you did it before it, then that would totally work, but after it would not work. So just keep that in mind. So now I want to show the mix and match of mapping. Quite simply, all you have to do is just say ML, and you can do MH. You can also do the M after the L. That totally works as well. Maci won't complain about that, but the reason why it's better convention to do the M first is because what's really happening behind the scenes is when maci detects this syntax, it's going to say, okay, I'm going to first, it's always going to first map, the name to the value, and then it's going to lock it. So this is a bad example because I'm not actually expressing a name, but let me go down here and do this. Sorry about that. So come down here and let's say we want to do L or H. We'll just do hard lock. So what's going to happen first, it's going to say, I want to map my name. I want to map this name to the value of whatever this name is. And then I want to hard lock it. So it's going to hard lock this name as well. So I want to map to inventory, and then I'm going to hard lock this name as well. And so whatever the last state of this value was, it's going to hard lock that in for this name. But again, this is only a name protection feature, right? So this would still map to this value, but if you ever tried to reassign this name to a new value, this actually would change because this is using regular assignment. This, let's say you changed this to an integer, let's just say 256. If you change this to an integer, this would update. But by the time, which happens very quickly, by the time it actually checked this reference and needed to tell it to update, this would actually throw an exception and say, hey, I'm currently hard locked on this name. Even though I'm mapped to it, I'm currently hard locked, and it would not update. So that would cause an issue. That would cause an exception and throw an issue. This would change, but this would not. And this would actually keep the last value that was stored before this was completely reassigned. But again, if you actually changed, if it was a mutable object and you actually just updated this object in place, then you wouldn't get any exceptions at all. Because again, it has nothing to do with the value protection, it has to do with the name protection. Next, I want to talk about multiline data, which only works for certain data types and follows the same Pythonic syntax as well. So let's take our list, for example, here. If you actually wanted to express this over multiple lines, you can simply do so like so. Especially when you have large data sets, it's a lot more human readable to express it over multiple lines like so. Now, if you express this over multiple lines, the syntax is the same, as Python, but you always need to have your ending bracket on a new line as the last character. So just keep that in mind. And maci automatically formats that when you actually go to save files. It automatically knows how to format its own data to protect against that. So but keep that in mind. If you were to manually express this, it just needs to be on its own line. But that's how you would do it with a list. And if you can imagine, it'd be the same concept for the rest of the sequence-based data types. So if we did like a tuple, same idea. And we'll do our set, same idea. And so that's would be our sequence-based types, right? So list, tuple, set. But we also have the dictionary, which you can put over multiple lines, and it would just look like this, and this is just for human readability, right? Just to keep it more human legible. But this functionality is totally supported if you wanted to express your data over multiple lines, and this is effective for these data types. Now, for triple quoted strings, you can also write those as well. So let's go ahead and do something like character, or we'll just say my phrase. We'll just say the character has a phrase or something. And you can do doubles or singles. Actually, I'll do singles just for fun. But you can do like single, triple quoted strings. And we'll just write, this day is going to be a very good day. And I wrote day wrong. Let's go ahead and fix that. But you can absolutely express triple quoted strings as well. And maci won't have an issue parsing that and retaining the syntax in there. So there will be a new line character. If you can imagine, there will be a new line character here before this text. There'll be a new line character before this text, and then another new line character at the end. Now, if you do express triple quoted strings like this, it's the same situation. You need to ensure that the triple quotes that you started with, the ending triple quotes, have to match and be on its own new line. And that's very important. However, if you have formatting inside of your string that shouldn't have new line characters, you can either strip them off, I would recommend, or you can actually just keep it in line if that's the case. But either way, you can write triple quoted strings. If you want to write, if you have massive text that you want to paste in your file here, you can do it over multiple lines with triple quoted strings, no problem. The documentation also talks about some of the quirks you might encounter. For example, let's say you had a double triple quoted string. Now, I shouldn't say that you might encounter. maci is actually smart enough to ignore this. So if it actually detected you started with a single triple quote, it'll ignore any kind of double triple quote terminating operators. And that's really what's going on here, is these ending points here is a termination operator in the way maci parses and handles things. It knows that, when you're starting a data stream, it knows to read whatever is there, and if whatever the last character is, that should be its termination operator, if you will. So it's the same concept here, but because I started with single triple quotes, it knows to ignore this and wait for this operation. Now, if you actually happen to want to keep single triple quotes in there, all you would simply do is just add an escape character, and it knows to ignore that, and it'll continue on until it finds the true one to terminate at. So hopefully that makes sense. Again, the documentation mentions this and talks about this. But that's essentially it for triple quoted strings. Now, some of the last things I want to talk about is just some of the unique or helpful stuff you can understand or to use within your file here. And that, of course, is comments. So we'll just do my comment, or actually we'll just type game save data. So, of course, this will be completely ignored. Totally fine. Now, the documentation talks about all the different variances. In fact, I'll just copy it and show you right here. So if we copy this, this is all valid syntax. This will be parsed no problem by maci. And so it looks very messy, but at the end of the day, you're just going to get these 3 variable names with their proper data structures. All these comments will be ignored, but I just wanted to show all the different variations. You can put comments in your data, no problem. Something I do want to mention though, if you use maci to store your data in code, like generate a file or override an existing file to store new data, these comments will disappear, right? Because it's going to ignore them. But if you actually write your data out and have comments in there, then that's probably going to be more of like a manual, like configuration file. You know, if you're managing a configuration file that doesn't really get updated, then obviously your comments will stay and persist. But something I recommend doing, in my opinion, the most times you'd ever really want to put a comment in a file like this is usually at the top. So that's really easy to do in maci. You can just, you know, create the comment right at the top and then have all your data right after. It's pretty straightforward. The next things I kind of want to show you is just some kind of quirky things to kind of look at. You can assign your data like this, or like this, or, you know, without spaces at all. That's totally valid, which is also valid in Python, right? You can totally do that. The PEP8 standard follows it like this, which I just recommend doing that. It's a lot cleaner to read. Again, the documentation talks about this, but you can totally do that. You can also do this with, let me go ahead and bring this back in. You can also do this with, you know, some of the other assignment glyphs if you want to do something like that. Again, following that standard, it totally supports that. So either way, I don't recommend doing that. I recommend writing it like this, way easier to discern. But some people like to write their stuff in a specific way where they might want it like super spaced out. I don't know. It's up to you, but either way, it's supported. And the last thing I just want to touch upon is some of the string literal prefixes that are supported. So let's actually jump down, and we're just going to create a basic one. We'll just call it my data for now, just to demonstrate. So string literal prefixes, what do I mean? So you probably have seen like, well, we have already seen the B, right? So we know the B, which is a prefix on the string to represent byte data, right? So we know when we see this, this is representing byte data, and that's kind of an important thing to understand. And so when this is read into maci and then transformed into a Python object, this will be a byte string, right? As we kind of are familiar with. But you can also do R, and you're probably familiar with R. R is for raw string in Python, and you can look that up in the Python documentation, but this will represent your data as a raw string, which is extremely helpful. And maci will have no problem reading that. You can also combine them. You can do raw byte strings. If you wanted to do RB, that's totally supported as well. You can also do U. If you're not familiar with U, U is the Unicode prefix string. So if you're into Unicode data, you can also do that. And maci will read that in. And that's it. You can't go any further past that, at least at the time of this video, which is the current version of maci, which is version 1. And you probably are wondering, well, are F strings supported? And the answer is no. F strings are not supported yet. Underscore or underline yet. That is not a feature of maci yet, but it is planned and understood, or I should say targeted in the future to support that feature. It's just not available yet, but right now you can only do the other ones. Again, this is more of a configuration or serialization language, but it is planned to support some of the more fun Pythonic features like F strings in the future, but currently not supported yet. But that's pretty much going to end it for the in-file language features that you can use in maci. But the next video we'll talk about is writing and expressing this inside of a string. But once you understand it from a file perspective, right, you'll basically be able to understand it within a string. But thank you so much for watching, and we'll see you in the next video. Take care.